I give the example. We are given here 3 points P, Q, and R. They are in a plane. So we want to find the vector perpendicular to the plane determined by P, Q, and R. The vector perpendicular plane will be when we have two vectors in a plane and we take their cross product, and this cross product, have you seen, the A cross B is a vector which is orthogonal to plane containing A and B. So we get here two vectors P, Q, and PR. We take the cross product, we get a vector normal to the plane or orthogonal to the plane or perpendicular to the plane. The second is we want to find the area of the parallelogram. We have seen when we are having A cross B, we get here from A cross B, we can from side A and B we can make a parallelogram, and we take the magnitude of A cross B, that gives me the area of the parallelogram. Then is the area of triangle. We have seen it here that we take half of the area of the parallelogram, that gives me the area of the triangle. And the unit vector, we get a vector in part 1, and we can just take the magnitude of that one and divide by that, we get a unit vector. So I just give you the example. We are having here 3 points P, Q, R. This point is point P, this point is point Q, and this point is point R, and I am having here two vectors PQ and PR. The coefficient of point PR minus 3, 0, and 5. This is my Q, and this is my R. So what's my Q is 2, minus 1, and minus 3, and my R is 4, 1, and minus 1. I have told you before, if we vector point A, this x1, y1, z1, and we're having here point B. Point B is x2, y2, and z2. I want to write the vector AB. Vector AB is equal to x2 minus x1, y2 minus y1, and z2 minus z1. Don't forget this definition of the vector AB. We'll apply this definition and find two vectors PQ and PR. So vector PQ, this here is number 1. First we find the vector. The vector PQ is the vector Q minus P. This is 2 minus 2, 3. Minus 3 is minus 1, minus 0. I get here minus 3, minus 5. So simplify this one, we get here 5. We get minus 1 and get minus 8. This is my vector PQ. Now I want to find vector PR. PR, then this is my x2, this is my x1. This 4 minus 3 is plus 3. Then 1 minus 0. Then minus 1 and minus 5. So the value I will get here, that is equal to 7, 1, and minus 6. So I get two vectors PQ and PR. So I want to find vector perpendicular to that one. The vector perpendicular to that one will be the cross product of these two vectors PQ and PR. And we write here the determinant I, J, and K. Then the coefficient of PQ, they are 5, minus 1, and minus 8. And then for PR is 7, 1, and minus 6. So these are my coefficient PQ and PR. Now I just simplify this one and get my result as I shown you before. The coefficient with I will be plus 6 and plus 8, 14I. Then minus J, it will be minus 30 plus 56. This is minus 30 plus 56 is 26J. Then we are having here with K is 5 plus 7, we have 12K. So this is my PQ cross PR. This is 14I minus 26J plus 12K. So that's this vector is normal to PQ and PR. You can just check it, multiply this one with any one of these two, you get the value equal to 0. And moreover, the cross product is a vector which is orthogonal to the plane containing PQ and PR. Next is find the area of the parallelogram made by PQ and PR. If I want to find the parallelogram, then obviously I extend this one and I can find here the parallelogram parallel to PQ. Here I write here, draw it parallel to PQ, and this is parallel to PR. This is a parallelogram, and the area of the parallelogram is area is equal to area of here PQ. I take here T, P, Q, T, and R. P, Q, T, R is the magnitude of PQ cross PR. So that gives me, and I want to find the magnitude of this one. And magnitude is equal to the vector the PQ cross PR. This is equal to root of 14 square plus minus 26 square plus 12 square. The square is take the under root. We are having here this equal to 196, and 26 whole square, that will be equal to 676. And then we have 144. We add it, we get the result of this one is equal to 1016, and we take the root of this one, that give me here 31.87 units, because we having the area, we take it unit square. So that's the area of the parallelogram. The next is the number 3. We want to find the area of the triangle PQR. And when we want to find the triangle, obviously it's very easy. For that one, we have the parallelogram, and we just make here the partition of that one, and we can just draw it here, and we can write this one. We divide into 2. Let's divide into 2, and here what's left, that's my triangle, and this triangle is half of the parallelogram. So I can very easily say that the area of the triangle PQR. So I can write here number 3. Number 3 is area of the triangle PQR is equal to half of the area of the parallelogram PQ plus PR. I have calculated this one. This is half of the root of 1016. Again, this is unit square because the area. So this was number 3. And again, number 5 is also very easy, because we want to find the unit vector. We have the vector PQ, PR, and we have the magnitude, and then the unit vector N is equal to PQ cross PR. This is my vector normal to the plane. This is vector normal to plane over. Magnitude of this one is PQ cross PR. So we are having both the things. This is here 1 over root of 1016, and then my vector PQPR is 14I minus 26J and plus 12K. So that's the completion of my result for this one. We're having the idea, using the idea of the cross product. We can use the idea of the cross product. We get all the results. The cross product PQPR is normal perpendicular to the plane containing this one. Magnitude of this one is area of the parallelogram. Half of the magnitude of this one is area of the triangle. And if you divide the vector by its magnitude, we get the unit vector. We divide the vector by its magnitude, we get the unit vector. As an application, we discussed the moment of the force about a point. This is a point here, and this is the arm of the arm, where we are going to apply the force. When we apply the force, for example, we have in the door, we apply the force, start rotating to open it or to close it. So and that is rotation clockwise. We say that is the moment of the force. So that's equal to the arm, that's PQ multiplied by F. That give me the moment of the force. We take this example, a vertical force of 6 pounds. This is attached to an axle. This is an axle here, PQ at the point P, and we are having this force, and this axle length is 3 feet. Is pulling it downward. I want to find the moment of the force in this case. Now this is force is in plane. This is my y axis, is my J, and this is my z axis, this is my K. There is no effect in xy plane, in along x axis. The whole thing is happening in yz plane. So we need 2 things. We need here the PQ and we need the force. Force is given to us. We can find our force. Our force, the magnitude of force is 60 pounds. Is acting downward, so this will be minus K. Upward is plus K, downward is minus K, and there is no other component of this one. So PQ is equal to minus 60K. I want to write in terms of the bracket notation, in the notation. So this is my definition of the force. Now I want to find PQ. Now PQ will be having the component of PQ along y-axis will be cosine, along z-axis will be sine. So we'll get here this is equal to, and magnitude is 3. We have 3 cosine theta, and this is along y-axis. Theta is over 60 degree. I said J. Then opposite to the theta, that's our parallel to z-axis is K. Then you plus 3 sine 60 degree, and we're having K. So we're having here 3 cosine 60 degree and 3 sine 60 degree, and we're having this one is our K. So cosine 60 degree is equal to 1 upon 2. So this is 3 upon 2 J, plus this is equal to 3 under root by 2. 3 into 3 under root by 2, we're having here K. So I have here my F, and I have my PQ. So I can find my moment of the force. My moment of the force is equal to PQ cross F. So what's my PQ? This will be I, J, and K. What's my PQ? If I write in a vector notation, the other notation, we have 0, 3 by 2, and 3 into under root by 3 by 2. That's my notation. So I get here 0. I have 3 by 2. I have 3 into under root by 3 by 2. And then I have my K. What's my K? My K is 0, 0, and minus 60 degree. Minus 60, the magnitude of this one. Now I solve this one. I know this is the upper triangular form. The magnitude of this one will be only equal to, this is minus 60 into 3 by 2 into K is equal to into I. And is equal to minus 90 I. That will be the moment of the force. And we say the magnitude of this one. When we want to find the magnitude, that's simply the magnitude is of the moment. The magnitude of the moment. The magnitude of the moment. We take the definition of the find the moment. Take the square and square root is equal to 90. We have the foot pounds. We're having here foot pounds. That's the magnitude of the moment of the force. So you can see here we can square it and take under root it of this one, that will remain 90. So that's the idea how we can find the moment of the force when we given the 2 points. Here is the lever, it's pushing downward. We can have the upward, then our K will be, the value will be positive. So according to that one, we can change our problem, we can solve it. There are many applications of the cross product in physics and in engineering. And also, as I always mention it, that I'm just putting my notes along with this one in Google Drive, and the link is given in the description of this one. Just go down and check it. If you have any question, you can ask me also. You can just put the question there, and we can see it if we can answer that one or help you in solving your problem. Thank you very much. Inshallah, we'll continue next time with the triple product, scalar triple product, and vector triple product.